All right, welcome to this explainer. Today, we're doing something wild. We are plunging miles beneath the ocean's surface to uncover some absolutely incredible mysteries. We're going to journey straight into the dark, crushing depths of the deep sea, a place we actually understand less than the surface of the moon. And we're kicking things off with a baffling discovery that completely shocked marine biologists and honestly sparked some pretty wild theories all across the globe.
I'm pretty sure this is how the first episode of The X-Files started. Seriously, those are the exact words spoken by a totally stunned scientist who was operating a deep-sea robotic sub back in 2023. Imagine you're staring at a live feed of the dark, rocky seafloor, and suddenly your crew just starts joking about horror movies and alien encounters. Well, that's exactly what happened, and as you'll see, our ocean clearly has a whole lot of secrets left to reveal.
Section 1. The Golden Orb Mystery.
So, picture this. The remotely operated vehicle, or ROV, named Deep Discoverer, was mapping the ocean floor about 200 miles off the coast of Alaska, and it spots something totally out of place. Resting on a rock 3,250 meters down, that's literally over 2 miles deep in the pitch black, was this strange, shiny golden mass. It was about 4 inches wide with a super smooth dome-like texture. But the weirdest part? It had a small hole right at its base, kind of like something had just hatched and crawled out. When this live feed went out, the internet and the scientific community absolutely exploded.
You can imagine the experts were just incredibly puzzled. I mean, they were genuinely struggling to categorize it, to the point where they were half joking about alien spacecrafts and mermaids' eggs. Was it a totally unknown sea sponge? Or maybe a protective egg case for some new giant deep-sea predator? To get some actual answers, the crew carefully deployed a robotic suction sampler, gently tickled this delicate little object, and just slurped it right up to bring to the surface.
Section 2. Solving the Deep Sea Enigma.
Now, cracking this case wasn't easy. It took researchers at the Smithsonian National Museum of Natural History over 2 years of really rigorous lab work. First, they threw the orb under a microscope and found these fibrous layers packed with stinging cells called spirocysts. That was a big clue, pointing to the coral and anemone family. But the mystery fought back. Their initial DNA barcoding totally failed because the sample was contaminated with DNA from other microscopic deep-sea life. Actually, it wasn't until scientists pulled out the big guns, advanced whole genome sequencing, that they finally got a nearly identical match to a known but incredibly rare deep-sea creature.
So, here is the huge reveal. That mysterious orb, not an alien egg, not a strange sponge. It was just the leftover biological footprint, basically the foot, of a giant deep-sea anemone called Relicanthus daphniae. And we are talking about a massive creature here. It has a foot-wide trunk and pale pink tentacles that can stretch over 6.5 feet long. The anemone had just detached itself, leaving that golden cuticle behind on the rock. It's such a wild reminder of how truly alien our own planet's deep oceans can be.
Section 3. The Invisible Creeping Heat. Okay, if we zoom out from our deep sea anemone, there's actually a much larger, completely invisible mystery happening, right there in the exact same deep water environment. While we're all distracted by alien-looking sea creatures, there's a massive, silent force moving through the abyss. It's called circumpolar deep water, or CDW. Essentially, it's this enormous pool of relatively warm, salty water circulating deep in the Southern Ocean. For the longest time, Antarctica's ice sheets were protected by this natural buffer of cold, dense water. But now, Cambridge researchers have confirmed that this warm CDW mass is actively expanding and migrating toward the poles. And it's directly threatening to erode the protective ice shelves around Antarctica.
1.26 kilometers per year. Let that sink in for a second. That is the very alarming rate at which this massive pool of deep ocean heat is marching straight toward the Antarctic continent. And this isn't some temporary blip either. This is a silent, creeping threat that's been confirmed by 2 whole decades of observational data. It is a consistent, highly directional trend.
And why does this matter so much? Well, it comes down to a really destructive process called basal melt. Because this incoming water is just slightly above freezing, it flows right underneath the Antarctic ice shelves and starts melting them from the bottom up. So the surface of the ice might look totally fine to us, but underneath, the structural integrity is just being completely hollowed out. You have to remember, these ice shelves are the vital breaks that stop the massive continental glaciers from sliding into the sea. If those breaks fail, Antarctica's inland ice sheets hold enough freshwater to raise global sea levels by a staggering 58 meters.
Section 4. Robotic floats mapping the ocean. Now, you're probably wondering, how on earth do scientists actually track an invisible wave of heat over decades in literally one of the most hostile environments on the planet? Well, they used an incredible technological trifecta. Historically, scientists had to rely on ships that took measurements maybe once a decade, which is obviously way too sporadic to see the big picture. So they took that historical ship data and combined it with continuous real-time measurements from a global army of autonomous robotic Argo floats. These amazing little robots just dive and drift all through the ocean, constantly pinging data. Then they threw all of that into advanced machine learning algorithms to stitch it together and fill in the blind spots. The result is a continuous 40-year monthly record of the upper 2,000 meters of the Southern Ocean. It proves beyond a shadow of a doubt that this deep water warming isn't just a model, it is our absolute reality. Section 5. Drilling the Doomsday Glacier.
Which brings us to the actual ground zero of this deep water threat. We're heading to West Antarctica, specifically to the Thwaites Glacier. It's this incredibly unstable mass of ice that has earned the ominous nickname the Doomsday Glacier. And Thwaites is an absolute monster. It's roughly the size of Great Britain or the state of Florida. If it were to collapse completely, it holds enough ice to raise global sea levels by 65 centimeters all on its own. Because its main trunk is moving incredibly fast and is full of dangerous crevasses, it's been largely unexplored. But recently, a super daring international team sailed the Korean icebreaker RV Arion right to Thwaites' most vulnerable point, the grounding line. That's the exact spot where the ice lifts off the bedrock and starts floating on the ocean.
So to understand exactly how this deep ocean heat is attacking the glacier, researchers are pulling off some absolutely extreme polar science. Drawing on 75 years of combined hot water drilling expertise, they literally heat water up to near boiling, about 90 degrees Celsius, and pump it at ultra-high pressure. This blasts a narrow, 30-centimeter hole straight through 2,000 meters of solid ice, melting about a meter a minute. Once they punch through the bottom, they drop sensors directly into the water below. They are literally watching the warm ocean actively melt the Doomsday Glacier in real time. It's just mind-blowing.
Section 6. A warning from the deep.
As we near the end of our deep sea journey, we really need to look at the massive global implications of all this converging data. Because what happens in the dark depths of the Antarctic doesn't stay there. Professor Sarah Perkey from the Scripps Institution of Oceanography summarized this crisis perfectly. She pointed out that over 90% of the excess heat generated by global warming is currently being stored right in our oceans. By absorbing all that human-made heat, the Southern Ocean circulation is physically changing. As she put it, it's almost like someone turned on the hot tap, and now the bath is getting warmer. The cold water buffer is shrinking, and that hot tap is just pouring deep-sea heat right onto the ice shelves. The ripple effects of this shifting ocean circulation are incredibly vast. We aren't just talking about West Antarctica anymore. Recent studies show that modified warm water is now intruding on East Antarctica's Denman Glacier too, and that one holds another 1.6 meters of sea level rise potential. These effects span the globe, directly threatening millions of people and vital coastal infrastructure in major Brazilian cities like Rio de Janeiro and Santos with severe flooding. On top of that, the massive influx of fresh water pouring in from these melting ice shelves threatens to weaken the entire global ocean conveyor belt known as the AMOC, which regulates climates all over the world. So I'll leave you with this final thought to ponder today. Our technology, from deep-sea robotic suction samplers slurping up bizarre anemones to global armies of autonomous Argo floats, is finally allowing us to map the mysteries of the abyss. But what we're realizing is that understanding our deep ocean isn't just about solving fun biological mysteries anymore. It's about predicting the literal future of our shorelines. The deep ocean is sending us a very clear warning right now. The only question is, how will we adapt?